Okay, so this is the lecture for Chapter 3, Section 2, Newton's Laws of Motion. Okay, so make sure you can answer these essential questions when you're done. Review vocabulary, acceleration, and here's our new vocabulary. Okay, don't be afraid, too, to take these little brain pops and stuff like this. It all will help you. Everything will help. Okay, so Newton's Laws of Motion. Um, We know Newton's story. We watched the movie, so we can skip over this first paragraph for this lecture. Just make sure you read it. 1665, Cambridge University. It closed because of the plague, and Newton went home to his country home. All right. Newton's first law states that an object moves at constant velocity unless an unbalanced force acts on it. Basically, what's in motion stays in motion. What's at rest stays at rest. If it is in motion, it will move in a straight line. Remember that cannon experiment where they shot the cannonball and Newton said it should continue to go in a straight line unless a force acts on it. The moon is not, it's in motion, but it's not moving in a straight line. Gravity of the earth is affecting it. What's in motion stays in motion in a straight line unless a force acts on it. What's at rest stays at rest unless a force acts on it. Okay, this is Newton's first law, and sometimes it's called the law of inertia. Inertia is the tendency of an object to resist any change in its motion. Okay, all right, now. Inertia and mass. The more mass an object has, the more mass it has, the more inertia it has. So the larger the mass, the more inertia. Okay, the larger the mass, the more inertia. Newton's second law explains, it actually explains his first and his third law. So Newton's second law of motion states that the motion of an object changes only if an unbalanced force acts on the object. Newton's second law of motion describes how the forces exerted on an object, its mass, and its acceleration are related. Okay, so force and acceleration. Relating force, mass, and acceleration. Newton's second law of motion. Acceleration equals the force of an object divided by its mass. I like to write it as F equals ma instead of A equals mf or F over m. But when we go to do the problems, I'll show you this in the homework. All right, so Newton's second law of motion states an object's acceleration is in the same direction as the net force on the object and is equal to the net force on it divided by mass. Newton's second law can be written as this: A equals F divided by M. Okay, right over here, F equals ma. The force equals the mass times acceleration. The higher the mass, and this is what I was meaning by inertia. If this object is at rest, if there's an object at rest, the bigger the m, the bigger the mass, the more force you're going to have to apply to get the thing to move. All right. So inertia deals with mass. The larger the mass, the more force that has to be used, or the larger the inertia. And here is the way to figure out these problems. We will do these problems in the homework. I'll do some homework help with you here coming up. Okay. All right, so Newton's third law of motion. Newton's third law of motion states that when one object exerts a force on a second object, and this is the key here, force. You've always been told for every action there's an equal and opposite reaction. Actually, Newton's third law is for every force there is an equal and opposite force. So Newton's third law of motion states that when one object exerts a force on a second object, the second object exerts a force on the first that is equal in strength and opposite in direction. Okay. So for every force, there's an equal and opposite force. Now, they do not cancel each other out. If, and I'm going to use the moon and the earth. If the moon and the earth's equal forces cancel each other out, we'd both go along our merry way. The moon would fly away in a straight line, and the earth would fly away from the moon in a straight line. But that's not happening. They don't cancel each other, they work together. Okay. Um, they always work together. Forces and interactions. Newton's third law states a very important fact. Forces are interactions between objects. For example, it makes no sense to say the box has a force of 30 newtons. Um, is this force acting on the box? And this is, I guess, talking about this question down here. Okay. All it is these forces work together. They work together. Okay. The forces work together at the same time. They do not cancel each other out. Very important. Okay, that's it for this lecture. I hope this helps you, and good luck on the homework.